All right, so this week we are actually getting into logarithms. Okay, so what are they? What does it mean? So forth and so on. So the most simplistic idea is this. If I have 2 to the x equals 8, because I understand what an exponent is, I can say, you know what, 2 times 2 is 4, times 2 is 8, so x must equal 3. Because it takes multiplying 2 by itself 3 times to get there. Okay, easy enough. But what if I said 3 to the x equals 8? Okay, this is where you get a random decimal. You don't just know it off the top of your head, so forth and so on. This is where logs come into play, because a logarithm is the inverse of an exponent. So that means that it undoes the exponent, so to speak. So, multiplication is the inverse of division. Addition is the inverse of... I have no idea what I just said. That's bad. Addition is the inverse of subtraction. On and on and on. So, when I look at it on the graph, remember we talked about in the last unit, what is an inverse? Exponential was when it was exponentially growing. So it was going up, up, up forever. It was getting closer and closer to 0 on the x-axis, but never actually touched it. So that means that so this is y equals b to the x. That means if I think about the reflection over y equals x, because that's what an inverse is, a logarithm must be the reflection of it over that dashed line. So notice that this one has an asymptote of x equals 0, whereas an exponential function has an asymptote of y equals 0, right? Like what it's getting closer to. Your graph, if you use a graphing calculator, it will deceive you. It will make you think that the graph ends, but the graph does not end. It goes on forever. So if you are messing up on domain and range, make sure that it's not your sneaky calculator that is causing you trouble. Okay. All right, so here's our basic properties. If I have log base b of 1, so for the first one, maybe we write that out to the side somewhere. Log base b of 1. That is how I say number 1, okay? This is true because if I think about it in the other form, b to the 0 power equals 1. Okay. I always start with the first number I see, I cross the bridge and come back. Okay. So if you are trying to convert from one form to the other, that's what you do. It works the other way as well. So like if I had, we were talking about earlier, 2 to the third equals 8. That means log base, so the base of the exponent, so log base 2 of, so cross what I call the bridge, the equal sign's the bridge, so cross the bridge and come back and pick up what you haven't touched yet. So log base 2 of 8 equals 3 is the same thing as 2 to the third power equals 8. Using that knowledge, that means b to the first power equals b in this one. In this one, b to the y power equals b to the y. Well, that makes sense. Those two equal one another, so that is correct. All right. What about this one? If I have the exponent, remember that's log base b of x equals everything else. Well, sure enough, just like last time, log base b of x equals log base b of x, okay? So that is your property. So what does that look like to evaluate a few? Well, if I convert forms, really what we're doing is converting forms. We're not really evaluating here. So start with the bottom number, pick up across the bridge and come back. So 2 to the third power equals 8. In this case, 3 to the 1/2 power equals square root of 3. So, in case you have forgotten, anything to a fractional exponent is like a square root, cube root, fourth root, whatever. So if it's to the 1/3 power, it's a cube root. So don't forget that rule. Okay, for this one, 5 to the -2 power equals 1/25. Again, remember your exponent rules. If you have a negative exponent, that really means you bring it to the denominator. So I really have 1/5 squared, which, sure enough, is 1/25. For the next one, 7 to the first power is 7. That is true. This one, log base 6 of 11 equals the exponent, but not as an exponent. And yes, those two equal one another. You'll have a maze to complete where you are doing that back and forth, exponential to logarithmic and logarithmic to exponential. So be ready for that. Quickly, before I press pause here, I do want to mention the inverses one more time. It's when your x and your y values are switched. So -2 to the x power is 1/4, because 2 to the -2 is really 1/2 squared, which is 1/4. This one would be 1/2. 2 to the 0 power is 1. 2 to the first power is 2, and 2 squared is 4. So hopefully that column is pretty easy. Then remember, so I'm blocking this off. If I want to find the inverse, I switch x and y. So instead of this point, I actually have 1/4 -2. Here I have 1/2 -1. Here I have 1 0, 2 1, and 4 2. So remember the inverses there. Same idea. This is why we touched on the inverse right before, because we must understand that exponential and logarithmics are inverses of